Hello, this is John Joshua Bilonia, back yet here again to perform another experiment. Experiment 3 regarding the MCC timer delay polling. So, first we're gonna create a new project, a standalone project, and we're gonna pick PIC 16F18875 as our chip, then XC8 as our compiler, and I'm gonna browse to a folder named experiment 3. Then I'll open this and I'll name it experiment 3. Now that we have experiment 3 here, we're gonna click on tools, embed, and we'll activate MCC. Okay, so now we have the content manager and our modules. First, we're gonna go ahead and start with our module. I'll designate again port RA4 as our output and port B4 as our input. Then, in our pin module, we'll rename this as D2 LED. And here, we'll rename our switch as switch 1. We'll uncheck this because it's digital, and on our switch, for our switch, we're gonna go ahead and have a negative value here. So this switch is for preparation for the second part of our experiment. So we're gonna go ahead, our system module, we have here our default settings with low voltage programming enabled, and our interrupt module already enabled. Then we're gonna go and click generate. So we have here our generation complete message. So we'll go ahead to our files in experiment 3 and access our main.c. So here in main, what we'll do here is insert a code that was typed in the laboratory manual. But before that, we should go back to our projects, into our resource manager, scroll down here and select the timer 0. So double click timer 0. We're gonna go ahead and click as 1 is equal to 256, and then clock source as FOC/4. Then we have here our requested period as 250 milliseconds, and the actual period will be 249.856 milliseconds, which is close enough to our desired. And then we'll go ahead and generate the code again. So we have generation complete. We'll go ahead to our main.c and add the code that is specified, which would be if timer 0 has overflow occurred. That means if the timer has already had overflow, then we'll have D2 LED toggle and timer 0 IF equals 0. So this code says that if the timer 0 has overflowed, then it will toggle the D2 LED and it will clear the timer overflow stack. so it can again overflow. So does what it does is just repeatedly toggles the LED according to the every time that the timer has overflowed. Now let's move on to our timer settings. But since we've already fixed our timer, we can now go ahead and build it. So we have our build successful message. So now that we have build successful message, we can now go ahead on our IDE and program it. So we already have our IDE here. I'll just connect the PicKit tree. While that is happening, we'll just go and browse for our hex file here. So we have here experiment 3, inner disk, default, production, and the hex file. Now it has loaded successfully. Now we can connect our PicKit tree, and the device has been found. Now program it. Now we have programming complete. Now we can disconnect and move on to our circuit. Okay, so this is our circuit. Here is our supply in this part. So now we're gonna go ahead and connect our supply. So connecting our supply, you can see that this LED4, or renamed as D2 LED, has been blinking periodically with an interval of about 250 milliseconds, or 1/4 of a second. So within 1 second, it blinks on twice and it turns off also twice. So the code is successful. Now we'll modify the code such that it will blink at an interval of 8 seconds. Let's move on to our code and modify it. Now back to our code. So my goal here is to have it blink every after 2 seconds, or that is 2000 milliseconds. So we all know that 250 milliseconds times 8 is equals to 2000 milliseconds. So we can now have 8 stacks of overflow before executing this code right here. So with that in mind, if first we're gonna have declare a variable. So let's say an integer called PSD because passed, the number of times passed since the overflow has occurred. So int PSD is equal to 0 initially, of course. So this is our stack count, and after that, in our while loop, if the timer has overflowed, of course we have PSD is equals to 1 plus its previous value, equals 1 plus its previous value. Okay, then after that, we're gonna check if the stack has come equal to 8. So if PSD is equal to 8, wait, we're just gonna have the close brackets here, or here, open bracket, open bracket, close bracket. So if PSD is equals to 8, then we'll have this code right here. We'll toggle it and reset it. Not to mention, we also need to reset our PSD to 0 so that it could start counting to 8 again. Then we'll close it right here. Okay, so this code, if every time that the overflow has occurred, PSD stacks up one at a time, then checks if it reaches 8. If it does reach 8, then the LED is toggled, because at that point, if PSD is equals to 8, then 250 milliseconds times 8 is equals to 2 seconds. So 2 seconds has already passed, and the interval of blinking would now be 2 seconds. So this would be the ideal setup that we can have. So checking here. So we have, okay, now that it has been modified, we can now build it. So we have now our build successful, and IDE has recognized the change in the hex file. So we'll now reload it automatically, and since our picket tree is already connected, we can now program it. Programming is complete. Let's now disconnect picket tree and go ahead over to our circuit. So we have here again our source. It is still not activated. The moment we turn this on, it should be blinking with an interval of 2 seconds. 1001, 1002, 1001, 1002, 1001, 1002, 1001, 1002. So as you can see, the LED blinks with an interval of 2 seconds. Now let's move on to the other parts of our experiment regarding the interrupt. Using the interrupt, here we are, we have reset our code. So checking again our settings here in our pin module, we have SW1 as an input with negative IOC, with our system module here enabled, and our timer here where interrupt is enabled. So now here we have to uncomment the interrupts that enable. Then after which, in our while loop, we'll present nothing, since the interrupt service routine will be the one who will do the toggling of the LED. That is the use of the interrupt. Since we're using, the approach that we're using here is via interrupts. So in order to access our interrupts, we'll have to go in our MCC generated files in our timer. So in our timer, we'll look for this section and include the mcc.h, one of our header files, and we'll go ahead and look for our interrupt service routine, or ISR. So we have here the ISR. So here we can add our code where it will be the one that will be toggling our LED. So it recognizes it. So now that we have it, we can now build our code. Okay, now that we have built successfully, we can automatically reload the file in our IDE and program it, since the picket tree is already connected. Okay, programming is complete. Let's disconnect the picket tree and go over our circuit. So here we are, resetting our code from the previous 2-second interval. Now we're using interrupts. So in order to do that, we'll have this blank, because the ISR or the interrupt of the timer will be the one that will be toggling on and off the LEDs, and then we're just gonna have to enable the interrupts here by uncommenting the enable lines. So checking our interrupt module, okay, system module, everything is fine. Also our pin module, where the negative IOC for the switch one is also present. Okay, now in our main C file, we'll do nothing but that, and then save it, and then we'll access our MCC generated files here and look for our timer, because the timer will be the one performing the interrupt service, or ISR. But first, we must include here the header file, which would be mcc.h, because header files bridge across the program so that it can read multiple parts of the code simultaneously. So we're looking for the interrupt service routine, or the ISR. Okay, so we have here the ISR. So we can add here our code. We should be toggling the LED. Now we can build our code. Okay, we have now build successful and the hex file has been loaded. Let's reload it and connect our pkit3. Go over to the IDE and wait for it to recognize the pkit3 and connect it. Connecting it. So this approach is using our interrupt service. So in here we'll have to activate this power supply, and you can see that the LED is blinking on and off with a period of about 250 milliseconds, where the timer has been designated to have a period of. So the extra challenge for the next part of the experiment would be to program the interrupt to be going on at an interval of 2 seconds. So going on over our code. So here we are back again with our code. So this time we need to have it set off at an interval of 2 seconds. In order to do that, I will make in the main a variable named PSD, just like on the previous one, but I'm gonna declare it as a volatile integer PSD and define it as 0. So volatile keyword here is just say that anytime or any point of the execution of the code, this value of PSD can change, so that we can freely move around the different values of PSD in order to stack it up again to the value of 8, just like what we did before. So here in the while, we can have here if PSD is equivalent to 8, then we can toggle the LED and reset PSD to 0. As you can see, the toggling is now in the main file, so we have to disable the toggling here in the ISR. So what we will do now is that since we have to access the PSD in the main file via determining if the interrupt, how many interrupts have happened. So in order to do that, we'll have to go to our timer, and every time the interrupt is happening, we have to increment our PSD by 1. So incrementing it by 1 every time the interrupt is happening, we can now have access to the PSD variable here in the main file. However, since these are two different files, we need something to access the PSD variable from the main C file back to the timer file. So in order to do that, we'll have to add the extern volatile int PSD here. So volatile int PSD is just, as usual, the volatile keyword. That means that the value can change anytime, as an integer, the PSD. Then extern keyword indicates that the variable is defined externally on some other file on the same program. So since this is on the same project or same program in a sense, so we can, the extern says that somewhere here in the MCC generated files, this the variable PSD is stored. So every time that the interrupt is going on, so the PSD will increment, it would send here according to this line to the main C file, so that we can now access our while loop here, so that the PSD will stack up every time. So as there are 8 interrupts, that is to say 8 interrupts, 250 milliseconds duration each, 8 times 250 milliseconds is equals to 2 seconds. So every 2 seconds we can toggle the LED, but we're still using the interrupt approach here, not the delay polling approach. So here we can now build our code. Okay, so now we have built successfully. We can now reload our hex file automatically and then program it, since the picket tree is already connected. So programming is complete. We're gonna disconnect the picket tree and move on to our circuit. So here we are in our circuit. Again, I'm gonna turn on the source, and let's see if it will blink at an interval of 2 seconds each. Oh, sorry, wrong port. Wait, let me fix my source. Okay, wait. Okay, let's try it again. Okay, so we'll activate the source. Now that the source is activated, we can see that the LED4 or the D2 LED is blinking with a 2-second interval. Okay, so that's it for our experiment 3 regarding MCC, timer, delay polling, and interrupt.